The reputation of the Toyota Motor Corporation was not built on speed, it was not built on luxury, it was built on a single bulletproof promise: indestructibility. For decades, the Toyota Tundra was the automotive equivalent of a granite block, unrefined perhaps, but eternal. We have seen million-mile Tundras. We have seen the 5.7-liter V8 survive abuse that would shatter a domestic truck. But that era ended abruptly with the release of the third-generation Tundra. What was supposed to be a technological leap forward has mutated into a catastrophic engineering nightmare that threatens to vaporize billions of dollars in shareholder value and, more importantly, shatter the blind trust of the American consumer. Right now, Toyota is executing one of the most complex and expensive recalls in automotive history. It is not a software update, it is not a sensor swap. It involves ripping the heart out of over 100,000 trucks. But here's the mystery that no one is talking about. Why did Toyota, a company obsessed with the Kaizen philosophy of continuous improvement, abandon a manufacturing process that had worked flawlessly for 20 years in favor of a new technique that introduced a fatal flaw deep inside the engine block? The answer lies in a microscopic layer of machining debris and a decision made inside the walls of the Huntsville, Alabama engine plant that has now spiraled into a global crisis. By the end of this documentary, you will understand exactly how a piece of metal smaller than a grain of sand brought the world's largest automaker to its knees. To understand the gravity of this disaster, we must first look at the economics of the recall. This is Recall 24TA07, or NHTSA campaign number 24V381. The scope covers approximately 102,000 vehicles, specifically the Tundra and the Lexus LX 600, equipped with the V35A TFS twin-turbo V6 engine. Initially, the industry speculated that Toyota would attempt a short block repair. A short block repair involves replacing just the lower section of the engine, the crankshaft, pistons, and connecting rods, while reusing the cylinder heads and turbos. It is a labor-intensive, high-risk procedure that relies heavily on the skill of the local dealership technician. But on July 25th, Toyota dropped a bombshell. They announced they would not be doing short block repairs. Instead, they are replacing the entire engine assembly, the long block. Let's run the numbers. A complete V35A TFS long block with turbos and ancillaries has a retail value hovering between $15,000 and $20,000. Add in the labor, roughly 20 to 30 hours of book time, to lift the cab off the chassis, drain fluids, swap the engine, and reintegrate the systems, and you are looking at a cost exceeding $30,000 per truck. Multiply that by 100,000 units. That is a $3 billion liability. For context, that is more than the GDP of some small nations, just to fix a manufacturing defect in one specific engine generation. This is not just a recall, it is a financial hemorrhage. But why? Why is the engine failing? The culprit is the V35A FTS 3.4-liter twin-turbo V6. This engine was the chosen successor to the legendary 3URFE 5.7-liter V8. The V8 was a dinosaur, thirsty and heavy, but it was invincible. The new V6 was designed to meet strict EPA CAFE standards, delivering more torque and better fuel economy through forced induction. It features a complex design, an aluminum block with laser-clad valve seats, a water-to-air intercooler system, and electronic wastegate actuators. It is a marvel of modern engineering. However, high-performance tolerances leave zero room for error. According to Toyota's filing with the National Highway Traffic Safety Administration, the issue originated during the manufacturing process at the engine plant, specifically the machining of the engine block. When an engine block is cast, it must be machined to precise tolerances. The cylinders are bored, the deck is flattened, and the oil galleries are drilled. During this drilling process, metal shavings, known as swarf, are produced. Toyota's production protocol includes a cleaning stage to flush this debris out of the block before assembly. The failure occurred because the cleaning process was insufficient. Metal debris was left inside the oil galleries. Once the engine is assembled and the truck is sold, this debris doesn't just sit there. As the engine runs, the oil pump circulates lubricant at high pressure. The debris is picked up by the oil and pushed through the system. Now, normally an oil filter would catch this, but the debris was located after the filter in the oil circuit or was substantial enough to bypass safeguards during the break-in period. The debris lodged itself in the main bearings and the connecting rod bearings. The bearings in a modern twin-turbo engine are under immense stress. The combustion pressures in the V35A are significantly higher than in the old naturally aspirated V8. The oil film between the crankshaft and the bearing is thinner than a human hair. When a piece of metal debris enters this space, it acts like a jagged rock in a shoe. It scores the bearing surface. This creates friction. Friction creates heat. The bearing material, usually a soft Babbitt alloy, begins to melt and seize. Once the bearing seizes, the connecting rod, which is moving up and down thousands of times a minute, can no longer rotate freely around the crankshaft. It snaps. When a connecting rod snaps at highway speeds, the results are violent. The rod can be thrown through the side of the engine block, resulting in a rapid loss of oil, a potential fire, and an immediate loss of motive power. This is why the NHTSA got involved. It's not just an inconvenience, it's a safety hazard. Imagine losing power while towing 10,000 pounds merging onto a freeway. That is the reality facing 100,000 owners. Now let's go deeper into the timeline. The affected vehicles were manufactured between November 2021 and February 2023. This dates back to the very launch of the third-generation Tundra. Early adopters, the brand loyalists who lined up to buy the first trucks, are the ones paying the price. Reports of engine failures began trickling onto forums like tundras.com and Reddit in early 2022. Toyota initially handled these case by case. They analyzed the failed engines, they saw the scored bearings, they saw the debris. Internally, there must have been panic. The switch to the TNGA-F platform was Toyota's biggest gamble in 20 years. They unified the Land Cruiser, the Sequoia, the Tundra, and the Lexus LX onto a single body-on-frame architecture. If the engine at the heart of this platform is fundamentally compromised, the ripple effects touch the entire high-profit truck and SUV lineup. The decision to replace the entire engine rather than repair it speaks volumes about the severity of the damage. In a short block repair, there is a risk that debris is migrated into the cylinder heads, the variable valve timing phasers, or the turbochargers. If Toyota paid a technician to rebuild the bottom end, but a single fleck of aluminum remained in the turbo oil feed line, the new engine would fail again in 5,000 miles. Toyota determined that the only way to guarantee the Toyota standard of reliability was to scrap the engine entirely and start fresh. This is the nuclear option. But this story isn't just about debris. It's about the Toyota tax. For decades, consumers have paid a premium for Toyota vehicles because of their resale value and reliability. You buy a Ford or a Chevy, you expect a few recalls. You buy a Toyota, you expect to just change the oil and drive. This recall strikes at the core of that value proposition. The Tundra competes in the most loyal segment in America, the full-size pickup market. Ford sells 700,000 F-Series trucks a year. GM moves similar numbers. Toyota has always been the outsider, selling 100,000 to 120,000 units, but selling them to people who wanted to opt out of the repair shop cycle.
If the V6 twin-turbo engine is perceived as fragile, the Tundra loses its only competitive advantage. We have already seen the market react. Used values for 2022 and 2023 Tundras have shown volatility as buyers become aware of the main bearing issue. Dealerships are reportedly struggling to move new inventory without significant incentives, something unheard of for Toyota trucks in the post-pandemic era. Furthermore, we must discuss the hybrid aspect. The recall specifically targets the gas-only models initially, but the iForce Max hybrid powertrain uses the same internal combustion engine. The difference is the electric motor sandwiched between the engine and transmission. While the recall documentation primarily lists the gas models, the mechanical architecture of the engine block is identical. This creates a cloud of uncertainty over the hybrid owners as well. Are their engines safe? Toyota says the manufacturing window for the debris issue was closed in early 2023, meaning newer trucks should be fine. But trust is a fragile commodity. Let's look at the competition. The Ford F-150 Power Boost Hybrid and the 3.5 EcoBoost have had their own issues, cam phasers, timing chains, but Ford has had a decade to refine the twin-turbo V6 formula. Toyota attempted to perfect it on the first try, and they missed. The 3.4-liter V35 AFTS is a technologically superior engine on paper. It has incredibly high thermal efficiency, it produces massive torque low in the rev range, but engineering complexity is the enemy of longevity. The more systems you add, twin turbos, electronic wastegates, complex PCV systems, the more failure points you introduce. There is also a cultural element here, the Made in USA badge. These engines are built in Alabama. These trucks are assembled in Texas. Toyota is, for all intents and purposes, a domestic manufacturer in terms of labor, but the quality control protocols are Japanese. The disconnect between the engineering design in Japan and the manufacturing execution in Alabama is where the investigation usually leads. Did the Alabama plant deviate from the protocol, or was the protocol flawed from the start? Let's return to the open loop we started with. Why did they change the machining process? Verified internal reports suggest that the production line changes were made to increase throughput efficiency. In the race to meet the massive demand for the new Tundra, the cycle time for engine block machining was critical. The specific orientation of the block during the cleaning phase, or the pressure of the coolant flush, was likely optimized for speed. This optimization created a blind spot where debris could get trapped in the oil gallery dead ends. It is a classic case of efficiency compromising quality. What happens next?
Owners of affected vehicles will receive notifications. Dealers will begin the arduous process of scheduling week-long service appointments. Loaner vehicles will be in short supply. The logistics of shipping 100,000 massive crate engines across the country are mind-boggling. We are talking about thousands of shipping containers of engines. But for the owner, the question remains, is the replacement engine actually better? Toyota claims the new engines are produced under a revised protocol with verified cleanliness standards. But once a vehicle has been dissected by a dealership technician, cab removed, wiring harnesses unplugged, vacuum lines rerouted, it is never quite the same as a factory-assembled unit. There are always broken clips, loose grounds, potential rattles. The factory seal is broken. This is the V6 disaster. It is a lesson in the perils of downsizing and the risks of complex manufacturing. Toyota will survive this. Their war chest is deep enough. But the Tundra's reputation has taken a hit that will take years to heal. The V8 is gone, and in its place, we have a high-tech marvel that proved to be mortal. The king of reliability has stumbled. The question is, can they get back up? Or will this drive loyalists into the arms of Ford and GM? For now, if you see a 2022 Tundra, listen closely. That knocking sound might just be the sound of a $3 billion mistake.